So what I'm going to talk about is the ozone uh, on this. And I need to think about light first. So if I draw a graph of light to 750, 800 some here, this is the visible spectrum. And then from 400 down to about 50 is UV. Okay. And then up here is IR and radio waves, etc. And as everybody knows, as the wavelength energy is proportional or equal to Planck's constant times the speed of light divided by the wavelength, which is equal to h nu. With that in mind, the smaller the wavelength, the higher the energy. So this is short wavelength down here at 50 nanometers, but high energy. Let me erase. So what happens is UV radiation interacts with DNA and we get damaged DNA. This happens to all life forms. And the damaged DNA reproduces, and so you get cancer and other ailments, cancer being the most common one. So we have to keep the UV radiation off our bodies. Otherwise, it damages the DNA in our skin and you get skin cancer out of it. So if I blow up my spectrum running from 50 to 400 nanometers, again, above 400 nanometers up in this range, 400 to 750 is visible light. And this is all in nanometers again. And so what you have here is from 120 to 220, these wavelengths, which will damage your DNA, oxygen absorbs them. Okay. From 50 to 120, both oxygen and nitrogen absorb them. So this is nitrogen in the atmosphere, which is most of our atmosphere, and oxygen. And so that cuts out everything from about here to here. Okay. And that gets rid of that. So our skin is safe. If we go above that, we go 220 nanometers to about 240. Oxygen absorbs it. Oxygen will take that and absorb that UV radiation, but it's weak. It doesn't get it all. And that's a problem. Fortunately, from 220 to 320, ozone absorbs. Okay. But it gets weak at the higher end, weak above 290 nanometers. If it's above 290 nanometers, it's weak. Okay. And so from 220 to 290, almost all the UV is absorbed. And so I forgot to label these. I'll do this now. UV C is from 200 to 280. This is UVC going from here to here. Let me put that in purple. UVC. UVB, of course, is 280 to 320. UVB is in this range, and UVA is in this range here. So we've essentially got most of the UV from 220 to 290. So this is good. We've gotten rid of all our UV A and a lot of the B on it. So what about the other parts of it? From 290 to 320, about 10 to 30% of the UVA gets through because the ozone is absorbing in this range, but not completely. And this works out because DNA doesn't absorb much. If you look at the graph on your book, you will see a graph that looks like this. And this is the UV, this is the absorption of DNA. The DNA absorbs really good at 290 and below, 280 or so. It's almost 100% absorption. And so this is the DNA absorbing, but here is the sunlight that hits the earth, and it looks like this. And so we have very little sunlight and very little absorption going through here. It's still a very dangerous area, which is why you have to use sunscreen on this. Okay. Um, so that's the deal with UV, and why ozone is so important is because it's the only thing that covers this very little area from 290 to 320 and 220 to 320. So here we're getting about 100%, and here we're getting zero UV gets through, zero UV gets through, and here 10 to 20% get through, all because of ozone. So without ozone, life would be impossible. Everything would get cancer and die. Anything above 400 is visible light, and it's fine. It's not causing us any harm. That ends my video on ozone. We'll talk some more about this later.